All right, physical students. So yesterday we were discussing about limits of rational functions. Now we are going to discuss three methods when the denominator is zero. I mean to say when the function is of the form of 0 by 0. So we have already assumed that f of x is a function, and let's say f of x is equal to g of x divided by h of x. Right? Now we want to find the limit. Let's say limit x approaches a, f of x, somehow this is equal to limit x approaches a, g of x divided by limit x approaches a, h of x. So this would be equal to g of a divided by h of a. In the case that this is 0 by 0, we want to we have three methods to find out the limits. In case h of a is not equal to 0, then we can just find this limit by direct substitution method that we have discussed last time. So in case it is 0 by 0, so we have three methods. The first method is, we call it factorization method. So actually there's a factor. Let's say we have a function x square minus 4 divided by x minus 2. If we want to find its limit at x is equal to 2, obviously this will be in the form of 0 by 0. But actually if you closely see, x square minus 4 divided by x minus 2, there's a factor x minus 2 above and x minus 2 below. If we cancel that factor out, the function is reduced to x minus 2. This is a polynomial function whose limit can easily be found. So basically it is possible to cut this also, because we know that x is never going to be equal to 2. We just say x approaches 2 in the limit. So that is a trick, right? So now in this, we have to remember few formulae. One is a square minus b square, that we know is simple. Then a cube minus b cube, you must remember this, is equal to a minus b into a square plus ab plus b square. And in case students, it is a cube plus b cube, it must be remembered that it is a plus b. Here instead of plus it will be minus. A square minus ab plus b square. If you expand it, you will get this only. Second one, and the third one is a raised to power 4 minus b raised to power 4. These formulas are widely used, is equal to a square minus b square into a square plus b square. Well, you can further factorize it, a minus b into a plus b, right? And we also know that from 9th standard, if f of alpha is equal to 0, means basically there is a function f of x. When we put x is equal to alpha, the function becomes 0. So what does that mean? Alpha is a 0 of the function. That means x minus alpha will be a factor of the function. Will be a factor of f of x. This we already know that. For example, let's say we have x square, minus 9. This is a polynomial function. So obviously when we know that when we put x is equal to minus 3 or plus 3, so the function becomes 0. So we can say x minus 3 and x plus 3 both are the factors of this. That is true. So let's go further. We can do a sum related to this. So he says evaluate L limit, what, limit x approaches to x cube minus 8 divided by x minus 2. This is the simplest one. So we can always write it like this. This is equal to limit x approaches to, so we can write it like this, x cube minus 2 cube divided by x minus 2. So obviously using this formula, we can convert this limit x approaches to, so x minus 2 will be common from here. What will be remaining would be x square plus 2x plus 4. Am I right? So when you put x is equal to 2, you get 4 plus 4 plus 4, that is 12 is the answer. Right? Similarly, you can do more sums, maybe there's some twist in the sums, but you can do them. All right? Let's do one more sum. We have, let's say we want to find out the limit x approaches 1 to divided by 1 minus x square plus 1 divided by x minus 1. Actually, we want to find out the limit of this. So we know that when x is equal to 1, you know, so it will be the form of what, it's infinity, infinity, becomes infinity, and here also it becomes infinity. It's infinity, infinity, so infinity to infinity. So we want to convert this in the form of 0 by 0. That's a trick. Otherwise, we cannot solve it because we know when the function f of x becomes in the form of 0 by 0, there are n number of ways to find the limit. So that's a trick we want to find out. So what we do is see that limit x approaches 1 2 divided by 1 minus x square plus 1 divided by x minus 1. We can write it as limit x approaches 1 divided by what? 2 divided by 1 minus x square. Can we write minus common? So it will be 1 divided by 1 minus x. Am I right? So this will be equal to what? This will be equal to limit x approaches 1, what? 2 minus x plus 1 divided by 1 minus x square. Am I right? You've taken 1 minus x square common. So this will be equal to what? Limit x approaches 1, 1 minus x divided by 1 minus x square. Very simple. So this is equal to limit x approaches 1. 1 minus 1 is common. So what do you get? Here 1 divided by 1 plus x, right? So this is equal to 1 by 2. We have converted this function infinity coming into this function, right? So here the limit is possible. Okay. So this gone. So there'll be some tricky sums also. Should do it. Now we talk about rationalization method. Rationalization method. This is also the method when we use when the function is of the form of 0 by 0. The limit is possible. So what do we do? See that we want to find out the limit x approaches 0. Let's say we have 2 plus x under root minus 2 under root divided by x. We want to find out this limit. This is also a question of NCERT exemplar. Okay. Now see when x is equal to 0, the function is of the form of when x is equal to 0, the function is of the form of what? 0 by 0. Okay. So we would like to rationalize, you know. So how do we rationalize? So what we do, we can rationalize the numerator by multiplying and dividing, its conjugate. So what's that? 2 plus x under root. Instead of minus, we'll write plus 2 under root, right? So we want to multiply and divide, you know, what by this. So what do I get? So I get this is equal to limit x approaches 0. What do I get? I want to multiply. So you see that you just multiply, you get 2 plus x minus 2. How? Becomes this square, this whole square, minus this whole square, because a minus b into a plus b. So this minus this. Am I right? So it will be here x into same 2 plus x under root plus 2 under root. Am I right? So this is equal to limit x approaches 0. You get here cancels with 2, x cancels with x. Right? So it will be 1 divided by 2 plus x root plus under root 2. Right? So the limit is possible. Put x is equal to 1. So you what do you get? This is equal to 2 under root 2 plus under root, that is 2 under root 2. That is your answer. Right? So here also you can find some tricky questions and you can do this. So I'll give you one question. I want the students to do this and submit the answer in the
So
comment.
please, so please give the time to note down.
Yeah, sure, why not? Why not? Why not? Please, please note down. Please note down. Alu. So now I give you two
Yes, sir.
examples, students. First example is find the limit. Please write down fast. Limit x approaches a plus 2x root minus 3x root divided by 3a plus x root minus 2 under root x. So how do we do it? So it's conjugate, just multiplied by plus, right? You can multiply the things by its conjugate. So you'll be multiplying and dividing this thing by a plus 2x root plus 3x root. Multiply and divide by that, and do some tricks. Possibly you'll have to multiply and divide once again also, two times. Then you get the answer. Just struggle a little bit, you'll get the answer. Okay, then guys, the second one, little tricky sums, but you can do it. Limit x approaches 1 to x minus 3 root x minus 1 divided by 2x square plus x minus 3. Find the limit when x approaches 1. You see that when x approaches 1, so this is actually 1, this becomes minus 1, and here it's 0. So 0 divided by when it is 1. So this is like 3 minus 3 0. So it's in the form of 0 by 0, right, Ishma? So your limit is possible. Okay, remember that when in the rational function, when g of x is positive and when h of x is 0, it's not possible to find the limit. So we have not touched any case. But when it is 0 by 0, the limit is possible. We're discussing the second method. All right, guys. So now we have discussed two ways in which a rational function can be converted to the value, in case we want to find its limit. Okay, but then we have the third one. This is using standard limit. Did you know this? Using standard limit. Okay, there is a concept in this, so I'm not going to simply tell you. I would love to derive the concept and then possibly go further. Okay, so whenever, as and when you have doubt, ask me to stop the video, don't worry. So guys, now if the limit is of the form, you write down, if the limit we want to find out is of the, I really ask you to write down. When I ask, do it. What इश्मा बोलो, क्या लिख रहा है, क्या लिख रहा हूँ मैं? X raised to power
N minus a raised to power n upon
x
x
minus what?
minus a.
ठीक है, या अर्जिंदर, what is this form? बोलो. X raised to power n minus a raised to power n divided by x minus a. Then we can find the limit by using a appropriate theorem, and these theorems we will derive it also. ठीक है ना? The theorem says, let n be any positive integer. Okay, then limit x approaches a, x raised to power n minus a raised to power n divided by x minus a is equal to, yes, n a raised to power n minus 1. Okay, okay, this is the theorem, but I'm not going to leave it like this. You may have asked, sir, ye kaise aayi hai na? So I have already thought of deriving it. So guys, you see that can how can I write x raised to power n minus a raised to power n? You get the idea from here. If I get x raised to power cube minus y cube, okay, or maybe a cube. So I know that this is in the form of x minus y into x square, yes, the plus xy plus y square. Okay, guys, the students who have studied binomial expansion would very easily, absorb this idea. You have studied binomial. Okay, so but then even if you don't know, no problem. So we can write x raised to power n minus a raised to power n as how? X minus a into, see here, what is this? X cube. What is this? 3 minus 1. I'll write x raised to power. No, 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 not 3 minus 1. Here it is x raised to power n. So I'll write x raised to power n minus 1. Right? Plus what? Plus a. Then x raised to power. One more down. You see, guys? Here x is 2. Ishma, you're able to see? Here x is 1. And what is the value for here x? Power?
0.
0. Beautiful. So from this we'll get a very easy idea. X raised to power. This is actually binomial expansion. X raised to power n minus 1 into a x raised to power n minus 2, right, plus dash dash dash, plus we will get a raised to power n minus 2 into x, plus the last will be what? X will be gone. A raised to power n minus 1. Right? So these things you don't worry in case you're not able to understand. We will do binomial expansion, so like it becomes very easy, very easy thing. Okay. So now we divide both sides, obviously by, want to divide both sides by, we want to get this one, x raised to power n minus this, so obviously we'll divide by x minus a, है ना, इधर cancel हो जाएगा, इधर o आ जाएगी चीज, what we want to find out. So what we get, guys? So we get x raised to power n minus a raised to power n. Yes, Ishma, I'll write here x minus a, right? Would be equal to, tell me, this is gone. So it will be x raised to power n minus 1 plus a x raised to power n minus 2 plus dash 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 plus a raised to power n minus 2 into x plus a raised to power, yes, n minus 2, and then next is
N minus 1.
n minus 1. Oh, very good. Arjinder has spoken. Very good. Good girl. So very simple. Now we will find its limit. It's very simple. All of them, all of these are which functions? Polynomial function. Simply put the value. I've already given a statement. In case of polynomial function, in case you want to find the limit is basically the value of the function at the prescribed point. Or point is where you want to find the limit, the value of the variable. Very good, very good. So guys, we will find limit what? X approaches a, x raised to power n minus a raised to power n divided by x minus a would be equal to what? Limit of all this? Limit x approaches a, all this, right? Am I right? So I'm sorry, I'm not writing all this. So imagine that I have written all this. So this will be equal to, now, limit of individual. So it will be limit of, that, remember the algebra of limits, limit x approaches a, If I have f of x plus g of x would be equal to limit x approaches a f of x plus limit f of x approaches a g of x. So I'll take individual limits. So what will be this? Yes, when Ishma, limit of x approaches a, limit x approaches a, it will be x raised to power n minus 1. Simply I'll put the value of x. I'll replace the x with a plus limit x approaches a x raised to power n minus 2 plus dash 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 plus the last is limit x approaches a raised to power n minus 1, right? So there's no x here. It will be unaffected. It will be same only what? A raised to power n minus 1. So guys, you will get this as, can anyone tell? A raised to power n minus 1. Can anyone tell me the next? This one. So this will be a into, see here, a into a raised to power n minus 2. This is equal to a raised to power n minus 1. Right? Interesting. Are you understanding, Ishma? This one?
Yes, sir.
Anna? Just a into a raised to power n minus 2 plus dash dash dash. And then what do you get? Tell me. Here, here, what will you get? Here, I'm sorry, I forgot to write this. Tell me what will be the limit of this? Limit when x approaches a. So it will be a raised to power n minus 2 into a. So that will be again a raised to power n minus 1. And what is last? Here x is not there. So simply write it in the same way, a raised to power n minus 1. Very good. So a raised to power n minus 1 we are observing is coming how many times?
N times.
N terms. So this is equal to n a raised to power n minus 1. Where I know the concept has to evolve, I will definitely, I will not do it in hazard manner. I promise. Fine. So we've done it. So tell me, now what is the theorem we have learned? Yeah, tell me. Limit. Come on, guys. Speak.
Limit x approaches a, x
Yes.
raised to power n
Minus
minus a raised to power n
divided
upon
by
x minus a
is equal to
n
a raised to
into
power, see,
a
I'll say
raised to
Ishma,
power n
a raised to
minus.
power n minus 1 plus a raised to power n minus 1 plus dash 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 plus a raised to power n minus 1 is how many times? N times. So this is equal to n into a raised to power n minus 1. Very, very important theorem going to help you in evaluating limits. That's all. So we have 2 minutes and we can do a sum also. So he says find out limit x approaches to x raised to power 10 minus 1024 divided by x minus 2. Come on. Yes, girls, help me do this. Very simple. Please help me do this. So this is equal to limit x approaches to, come on, x raised to power 10 minus, yeah, I'm going to tell you,
2 raised to power 10.
10, beautiful. 2 raised to power 10 divided by, don't get excited, divided by x minus 2. So this will be equal to, remember the formula, always write down the formula, always n into a raised to power n. Whenever you think, oh, it's very simple, think you're going to make a mistake, write down the formula, put the brakes. Okay, so this is equal to, come on, what is n? Students, what is n?
10.
10 into a, what is a? What is a?
2.
Correct. 2 raised to power n minus 1. And n minus 1 is? So this is equal, am I right? 10 into 2 raised to power 9. So this is equal to 2 raised to power, come on.
2 raised to power 9 is equal to 512.
No, this is equal to 2 raised to power 9 into 10. So 2 raised to power 10 is, 2 raised to power 10 is given, 1024
Answer is
divided by 2.
5120.
So this will be 512 into 10. Apply some brain. Otherwise you go to drain. 5120. Right? Students, hope you like the lecture. You know, rest all is tricks. Rest all is tricks. There's no other concept in this, okay? But yes, I'm going to give you two more sums in this also, which are tricky. Okay, okay, fine, students. So we have 4 minutes. We can do more sums. Okay. So are you ready, girls? Shall we do more sums? Very interesting sums now. Shall we do on this method only on the basis of using
Standard limits.
standard
Standard limits.
limits? Okay. So let's do one more. Wait a minute. Okay. Let's do this sum. We have limit x approaches 1, x raised to power 7 minus 2 x raised to power 5 plus 1 divided by x cube minus 3x square plus 2. This is also NCERT exemplar problem. So think about this. First, is it from 0 to 0 by 0 form? Put x is equal to 1. 1 minus 2 plus 1. Yes. 0. 1 minus 3 plus 2, 3 minus 3, 0. Good. It is of the form of 0 by 0. So we have a confidence we can catch it. Whenever you have something of the form of some positive or negative number divided by 0, leave it. Don't do that. Don't waste time.
Yes.
Whenever you get this form, plus something minus something divided by 0, don't do it.
Because
simply write limit.
It does not exist.
We cannot find the limit. Okay,
Yes.
fine, limit doesn't exist. You can say that also. You can say no problem. So here limit is possible. We have to catch it somehow. So how do we do it? How do we do it? So fine. So this is equal to limit x approaches 1. How can you do it? How can you do it? See that? How do I do it? I write like this: x raised to power 7 minus x raised to power 5 minus x raised to power 5 plus 1. Can I write like this? Right? So similarly, now think, what will I do here? X cube minus x square minus 2x square plus 2. Right? Why did I do like this? Because here I'll get x square minus 1. Here also I'll get x square minus 1. So now I'll change the color. Black is great. Okay. So there, now what do you do? This is equal to limit x approaches 1. So what is common in these two? X raised to power 5. So you get x square minus 1. Am I right? And here you take minus 1 common. So what do you get? X raised to power 5 minus 1. Down, what are you getting? You want to have? So you take x square common. So what do you get? X minus 1. Am I right? How you take minus 2 common, what do you get? X square minus 1. All right. Some matching things you're getting. Okay. So now you are dividing numerator and denominator by x minus 1. Okay? Or you can just say multiplying and dividing the whole this by x minus 1. So what do you get? So this is equal to limit x approaches 1. So what do you
So
get?
why did we do this?
Why did we do this? So you get this by practice, because ultimately you want to bring this to this level. Which level? X raised to power n minus a raised to power n divided by x. Tell me. X raised to power n
Minus A.
minus a. See that how I'm bringing it. Okay. So how do we do it? Do a little bit of practice and then you can do it. So you are dividing everything by x minus 1. Okay, so this is x raised to power 5 into x square minus 1 divided by x minus 1. Right? Minus what? X raised to power 5 minus 1 divided by x minus 1. Is it right? Then hold this. What will I get here? X minus 1 will cancel. I'll get x square. So here I'll get minus 2 into x square minus 1 divided by x minus 1. Is it right? So what is this coming? Tell me. Limit x approaches 1. Can you tell what is this? Simple. X square minus 1